close things, today's video is looking at converting between the radical form and the rational exponent form. So here we have a radical sign, so that's why it's called radical form, and over here we have a fraction. That's what a rational number is. It's simply a fraction in the exponent. That's why it's called rational exponent form. So what we have here is, in the radical form, this little number over here that you don't usually see because we usually call this a square root. We don't deal with the other roots very often in Algebra 1. So this is a 2 here, but we just don't always write it. And this is the exponent that is on whatever the base is inside here. For this x, we write that as the exponent over the index. That's how we get that fraction. We take the exponent from the radical form and the index from the radical form and write them as a fraction, e over I. So here's another way to look at it. If you have a fraction, e to the I, you have this in rational exponent form, you can rewrite it in radical form, taking the numerator and putting it as the exponent under the radical sign and using the denominator as your index. So this e stands for exponent. The I is our index. This little symbol here, that's our radical. And the x itself is simply our base. So we have two quick examples at the bottom of this little section here that shows us how to take radical form and simplify it. So here we have, for our first problem, we have an index of 4 and an exponent of 8. So we have the fourth root of 5 to the 8th power. We are now going to rewrite that as a rational exponent. So we have 5 to the 8 over 4, but 8 over 4 can be reduced to 2 because 8 divided by 4 is 2. So that's taking 5 and raising it to the second power, which is indeed 25. For our second problem, they're asking us to take the cube root. That's what it means when it has a 3 as an index. We take the cube root of 4 raised to the 6th power. So here we rewrite it in rational forms. We have 6 over 3. So 6 over 3 will simplify to be 2. So here we take the 4 and we square it and we get 16. So now on the other side, the right-hand side of this paper, we have simplifying expressions with rational exponents. So what we're going to do here is very briefly go through these properties to remind you what they are. Whenever you have a negative exponent, you make it a positive by putting it in the denominator. If there's a negative in the denominator, it goes to the numerator as positive. When you have like bases and you're multiplying, you add their exponents. And when you have like bases and you are dividing, then you will subtract their exponents. Over here we have two properties at the same time. We have the power of a product, which means you take each factor and raise it to a power. But what happens here is you have a power being raised to a power. So m is being raised to the p power, so we will multiply those together. B has an exponent of n, which is being raised to the p power, and so we're going to multiply those two together. And that's as far as we can get with those. Now we have this example here of 2x to the 3/5 power, all being raised to the 5th power, being multiplied by y, and that's going to be our numerator. And in our denominator, we have 4 being raised to the 1/2 power, x to the 3rd, y to the -2. So we've got a lot going on here with this one. So first thing I'm going to do is rewrite this by applying this rule basically right here. I have a power to a power because this power is going to get raised to this power. Remember that 2 does have a power, it's a 1, and it's going to get raised to the 5th power. So 2 to the 1 times 5, which is 5. X to the 3/5 times 5 actually gives us a nice pretty 3. And then we have our y. So there is our numerator, simplified somewhat. Now I'm going to take this 4 to the 1/2. Since this will not reduce to a nice whole number that I can square or cube that 4, I need to go ahead and write it in radical form. So I now need a radical sign. The 4 goes underneath. The 1 is my exponent. The 2 is my index. So this is the square root of 4. Then we have x to the 3rd, and that y to the negative 2. I'll take care of the y to the negative 2 here in just a few minutes. All right, so now I'm going to rewrite this and simplify a few things. I'm going to leave this 2 to the 5th, x to the 3rd, y, and I'm going to call that y to the 1st power. And here I'm going to simplify the square root of 4. What number do I multiply by itself to get 4? That would be 2. So I'm going to end up with 2, x to the 3rd, y to the negative 2. So here I have simplified both the numerator and denominator. Now I can start looking at like bases, since this is division, and see if I can do anything with that. Indeed I can. I have 2 to the 5th over 2 to the 1st, so that's going to be 2 to the 5 minus 1 times x to the 3 minus 3 times y to the 1 minus negative 2. Notice how I put that second negative 2 in parentheses. So I'm going to simplify this part. 5 minus 1 is 4, so I'm going to end up with 2 to the 4th power. My x is going to be raised to the 0 power, and this y, 1 take away a negative 2 gives me a positive 3. I have one more step to get my final answer. I have 2 to the 4th power, so 2 raised to the 4th power is 16. X to the 0 is 1, and 1 times 16 would just be 16. And then y to the 3rd power. So all of this right here that looked so bad and nasty is simply 16 times y to the 3rd power. So here is converting between radical and rational exponent form, or rational exponent form to radical form. You need to be able to go in and out of these two forms, go from one to the other and vice versa. And then here's an example of how you might go about simplifying. How you apply these rules is going to be a matter of how you see them and when you see them. So try to take care of this rule first whenever possible, and then especially if you have a fraction, just simplify your numerator and denominator, and then it's a matter of simple subtraction and you're done. So this has been converting between radical form and rational exponent form.